Design pattern. Reusable solutions to common software problems. Agenda. Object-oriented design. Design patterns history. Why design patterns? Pattern selection lifecycle. Getting started. Basic workflow. Creational, structural, behavioral. Object-oriented design. Object-oriented design organizes a program around objects that bundle data and behavior, communicating through well-defined interfaces. If requirements change, a well-designed set of objects can absorb the change in one place instead of rippling through the whole codebase. Almost every large, long-lived codebase eventually needs a shared vocabulary for organizing objects and their relationships. Any team maintaining software for years benefits from proven, well understood ways to structure their design. Reinventing the same structural solutions from scratch on every project doesn't scale. Ad hoc design and pattern based design. Ad hoc design solves each new problem from first principles, often reinventing a solution that already has a name. Pattern based design reaches for a catalog of proven, named solutions to recurring design problems. Ad hoc, one off classes, undocumented conventions, reinvented each time. Pattern based, singleton, factory, observer, strategy, named and documented. Problems without design patterns. Single point of failure. A tightly coupled design means one change ripples unpredictably through the codebase. Every developer invents their own vocabulary, making code reviews and discussions slower. Hard to onboard new engineers without a shared way to describe common structures. Difficult to swap an implementation without rewriting the code that depends on it. Every team reinvents solutions to problems the industry solved decades ago, misses out on decades of collective experience about what tends to work and what doesn't. The design pattern catalog system. Patterns are documented with a name, an intent, and a reusable structure kept as shared team knowledge or a wiki. Class relationships are commonly captured in UML diagrams before being implemented in actual code. Patterns are grouped into families that solve related kinds of problems. The three classic gang of four categories: creational, structural, behavioral. Design pattern advantages. Gives teams a shared vocabulary, so a single word like observer replaces a paragraph of explanation, speeds up design decisions and code reviews by naming familiar structures, encapsulates decades of accumulated experience about trade-offs that actually work, makes code easier to extend since many patterns are built around swappable, decoupled pieces, eases onboarding since new engineers can look up a pattern instead of reverse engineering intent, applies across languages and frameworks from enterprise Java to modern web frontends. Everything is an interface almost. One huge benefit is that most patterns follow the same core principle: program to an interface, not an implementation. Depending on an abstraction instead of a concrete class makes it easy to swap implementations later. Composition is favored over inheritance in most patterns, keeping designs flexible instead of rigid. Encapsulating what varies isolates the parts of a system most likely to change. Once you see this principle, you start recognizing it inside almost every pattern in the catalog. Singleton and factory. Singleton ensures a class has only one instance with a single global access point. Factory delegates object creation to a method instead of calling new directly. Strategy pattern. A strategy pattern lets an algorithm be swapped at runtime behind a common interface. Observer pattern. The observer pattern lets subscribers react automatically whenever a subject state changes. History. Rooted in the work of architect Christopher Alexander, who described the reusable patterns for physical architecture in the 1970s, adapted for software by Eric Gamma, Richard Haim, Ralph Johnson, and John Lysides, collectively known as the Gang of Four. Their 1994 book, Design Patterns Elements of Reusable Object Oriented Software, catalogued 23 classic patterns, became foundational reading for object oriented programmers throughout the 90s and 2000s. Still widely referenced today, even as some patterns evolved or became built into modern languages themselves. Why design patterns? Shared vocabulary. A name like decorator replaces paragraphs of explanation. Proven solution. Decades of real world use back up each pattern's trade offs. Easier maintenance. Decoupled, well named structures are simpler to change safely. Faster onboarding. New engineers can learn the pattern instead of the whole codebase's history. Language agnostic. The same ideas apply across nearly every object-oriented language. Still evolving, functional, and modern languages have reshaped how some patterns are expressed. The Gang of Four catalog. The original 1994 catalog organizes all 23 patterns into three families by purpose. Creational patterns control how objects are created. Singleton, factory, builder. Structural patterns control how objects are composed. Adapter, decorator, composite. Behavioral patterns control how objects communicate. Observer, strategy, command. Pattern selection life cycle. Spot the problem, identify. Match a pattern, choose. Implement it, apply. Clean up design, refactor. A recurring problem is identified, matched to a pattern whose intent fits, implemented deliberately, and the surrounding design refactored to fit cleanly. Getting started with design patterns. This leads us to the three steps that turn a problem into a pattern. Identify the problem. Notice a recurring structural or behavioral issue in the code. Match a pattern. Find a pattern whose intent matches the problem. Apply deliberately. Introduce the pattern only where it earns its complexity. Basic workflow. Identify the problem and identify the pattern suitable for the pattern. Apply the pattern. Applying, refactoring, and reviewing. Some call apply, refactor, and review design patterns everyday loop. Patterns are a means, not a goal. Apply them where they solve a real problem, not everywhere. Refactoring toward a pattern is often safer than designing it in from day one. Code reviews go faster when both people recognize the same named pattern. Overusing patterns can add needless interaction. Simplicity still wins with no real variation to support. Supports many workflows, new feature design, legacy code refactoring, API design. Works the same across nearly every object-oriented language and framework. Any questions? Thank you.